Diphtheria is a serious bacterial infection caused by the bacterium Corynebacterium diphtheria. The infection primarily affects the throat and upper respiratory tract. The bacterium itself is not harmful, but when the bacterium is infected with a phage virus, it produces a toxin that is harmful to the human body. This toxin is synthesized as a single polypeptide, but its active form is proteolyzed to two polypeptide chains linked by a disulfide bond. The A portion is an enzyme that constitutes the toxic part, and the B portion is a mechanism that binds to the host cell receptors. Once the A portion enters into the cell, it affects the ribosome's ability to protein synthesize, further killing the susceptible cell. Diphtheria is spread only among humans and is spread via two main routes: airborne droplets and contaminated personal items such as tissues. After a person is infected with diphtheria, there is a 5-day incubation period. Early symptoms are that of the common flu, such as fever and nasal discharge. However, after the initial symptoms have appeared, within 12 to 24 hours, a pseudomembrane, a thick grey membrane, will begin to form on the back of the throat and upper respiratory tract, leading to other symptoms such as sore throat, difficulty swallowing, and a barking cough. If the toxin, however, enters the bloodstream, it can result in life-threatening complications such as myocarditis, inflammation of the heart, paralysis as a result of nerve damage, polyneuropathy, and kidney failure. When the macrophage cells detect the pathogen, they phagocytose it and release cytokines to recruit more immune cells, causing the inflammatory response. The cytotoxic T cells have little effect in the fight as they target the B part of the toxin on the infected host cell, being too late as it is already dying. The T helper cells can be split up into T helper 1 and 2. T helper 1 activates more macrophages which phagocytoses the pathogen and removes the infectious bacteria. T helper 2 is a link between the T-mediated response and the humoral response. They transform B cells into plasma cells, which creates antibodies. These antibodies attack the B component of the AB toxin, disabling its ability to connect and infect the host cell, neutralization. As a result, if the toxin is prevented from connecting to the cell by the antibodies, it is unable to harm the host cells anymore. Vaccines work in two ways. One is by supplying antibodies from another organism. This is known as passive immunity, where it is often short-lived and provides immunity to those who have an inefficient immune system, e.g. babies and chemotherapy patients. The other is by exposing the body to a form of pathogen in a safe way that will stimulate the body defenses to make antibodies against this disease. The form of pathogen will either be a living but weakened form, an inactivated pathogen, or a subunit of the pathogen. The body will then store memory B cells, and when it is exposed to the disease again, it knows how to produce the needed antibodies. Public vaccination programs play a huge part in the control and prevention of diseases. The vaccination program recommended by WHO, a 3-dose primary vaccination followed by 3 booster doses, plays a vital role in the prevention of diseases such as toxin-producing infections. This program has allowed countries that follow it to become almost completely free from these infections, as it provides an adequate immunity for the participants. For example, in the United States, before the diphtheria vaccination was in place, there was 206,000 cases of diphtheria in 1921. After the implementation of the WHO program, diphtheria was almost eradicated in the United States, demonstrating how this vaccination program has controlled and prevented the disease of diphtheria. This vaccination program has the same effect on other toxin-producing infections, such as tetanus and pertussis. Also, the vaccination program advised by WHO, the recommended immunization list, has helped control and prevent diseases such as smallpox and polio, as it informs countries how to correctly administer the necessary vaccinations to provide resistance against life-threatening diseases. As a result of this recommendation immunization list, many countries have utilized it and are therefore able to control and prevent many vaccine-preventable diseases. Vaccination programs are extremely effective in preventing the spread and occurrence of diseases if utilized correctly. The spread of diphtheria before vaccination was huge, especially within the United States, having 206,000 cases in 1921 with 15,520 deaths. After the vaccination programs were put in place, the numbers declined greatly, and then further declined again when WHO included diphtheria in the list of recommended immunizations in 1974. The vaccination program almost eradicated diphtheria in the United States, with only having 5 cases in the last 10 years. The vaccination programs for diphtheria are extremely effective in preventing the spread and occurrence of disease when utilized as shown in the United States. But there are some countries that still don't have vaccination programs, resulting in the continuous spread of diphtheria. The eradication of smallpox proves the effectiveness of vaccinations. It was estimated that in the 19th century, it was killing about 400,000 people per year. In 1796, Edward Jenner discovered cowpox and its ability to provide immunity against the more lethal smallpox. As a result, in 1796, Jenner produced a vaccine against smallpox. In 1917, routine vaccinations against smallpox commenced in Australia, with the last case of smallpox in 1938. By the 1950s, only those who were at risk of the disease were given the vaccination, such as those travelling to countries where smallpox was still present. In 1967, WHO started a massive campaign to eradicate smallpox, with doctors from all over the world going to towns to administer the vaccine. The last known case of smallpox was in 1977 in Somalia, and in 1979, WHO declared smallpox eradicated, clearly providing the effectiveness of vaccination programs. Polio was a common childhood disease in all countries, until the 1960s when polio vaccination programs started. In Australia, there was a major epidemic in the year of 1938 when over 4,500 cases were reported. In 1953, Jonas Stark developed a vaccine against the virus, and in 1956, it was administered via injection to Australians, and the number of cases rapidly declined. In 1966, the Australian vaccination program replaced the Stark's vaccine with an oral vaccine. And in 2005, the oral vaccine was replaced again with an inactivated polio vaccine. In 2000, the entire Western Pacific region was declared polio-free by WHO. Polio was on track to becoming the second disease ever to be eradicated. However, in poor countries, there are still cases of polio as they are not able to access the vaccinations to prevent the disease. Some people in society, such as the Australian vaccination skeptics, don't believe in the effectiveness of vaccinations and believe they are not safe. However, some unvaccinated people can still have some immunity from the disease within their community if a majority of the population is vaccinated. This is called herd immunity. Therefore, vaccination programs are extremely effective in preventing the spread and occurrence of diseases. Diseases such as diphtheria and polio can become like smallpox and be eradicated if vaccination programs are utilised to their full potential by all countries.